Hey friends, welcome back. So in the previous video of this series, in this series of assembling the TV typewriter, we left off on the on the sixth step of the construction manual's construction steps outlined by Lancaster, and we basically connected these jumper wires to the B lines here, B1 through B7, I believe. And the other end connects to some of these letters here, basically different clocks on the timing board. And we were able to display the full alphabet, special characters, punctuation, and also the numbers in multiple lines on the screen to our right here. And so yeah, basically we ended up here, and it says do not go beyond this point unless you're completely and stably displaying the entire alphabet, repeating 8 times. So I believe we were pretty much displaying all the characters and punctuation numbers pretty stably. So I think it's time to move on. And this is where we left off. This is where our setup was left off at. So the next step is number 7, and it starts off by assembling the cursor board. And if you remember from previous videos, this is the cursor board, by the way. In the previous video, we already assembled, where I actually added the Molex connectors, the top female ones and also the bottom male ones. We actually did it for all of these boards at one time. And we already assembled all of the other boards. So we assembled the mainframe board, which is the power supply and the circuitry for the TV output. And also the memory board, which contains memory functionality. I don't think we still have a couple of ICs that need to be installed into the memory board, particularly the shift registers, the 2524 Signetics. So we'll actually do that in this step, in this video. We also completed the timing board and tested it out to make sure that it was actually working properly. And it appeared to be working properly. By the way, I installed this capacitor here. It's a trimmer capacitor to try to adjust the frequency of this oscillator, which is a 4.5 megahertz. And the TV typewriter actually needs a 4.561.92 megahertz. And unfortunately, I couldn't find a frequency like that, so I used a 4.5, and I tried to play around with the frequency. Basically adjust the frequency with the trimmer capacitor, and it adjusted it slightly, made the screen look a little bit better, but it's still not there. We still see some issues with the display. So the issues that we're seeing with the display, I think, is actually tied to this frequency deviation. So we'll probably resolve this at a later, once we complete the rest of the circuitry, we'll try to resolve this at a later time. And I might have some options on how we can actually resolve this, but we'll talk about that later. Okay, so let's I will put this aside, and then we can start the assembly of this board. By the way, these boards, I had to basically swap them around all the time, putting the timing board down below just so I could access the memory board and do some probing around, testing things, and vice versa. And just removing and adding the boards back in can be tough sometimes. And I already wounded myself a little bit somehow. I don't know how, but I wounded maybe on this connector or something while just swapping these boards around. So try to be careful, go a little bit slow, and just slowly and carefully remove the boards whenever you have to remove them. Okay, let's put this mainframe, I guess the entire setup aside, and start the assembly on the cursor board. By the way, these boards are actually available for sale at www.calenture.com, and the PCB set includes a mainframe board, a cursor board, a memory board, and a timing board. If you ever want an additional memory board, because you might want a page 2 or page B, let me know and I'll make it available separately as well. Okay, so as usual, and in fact, the first step in the instructions, if you remember on page 11, actually set to install all the MOS connectors, which we did on all the boards, but also it's set to install all of the decoupling capacitors and the jumpers on all the boards. We actually skipped that and decided to only install the jumpers on the mainframe, well, actually on each board, successive board, while assembling each board. So we skipped that part for the cursor board as well. So the first thing we're going to do is install these jumpers right now. Next, we'll install the resistors, and we'll use the parts list here to find the correct resistor to install into each position here. So, for example, R1, R5, R8, R13, R16, R21 are all 1000 ohms, so 1 kilo ohm. Alright, so we got the resistors installed. Next we're going to install the IC sockets. And I'll be using this, for example, this is an 8-position IC socket. This is for the 555 timer. This is the same one that I used on the memory board for the shift registers. And also the 14-position ones, same as the other ones, from the same time period, which I believe are from the same time period. And again, we're gonna install them and just gotta make sure they're oriented the right way with pin 1 facing right. So all the IC sockets will be facing right. Okay, we installed the IC sockets, and the only thing that's left to do is to install the capacitors and a transistor. So I guess what we're going to do first is install the capacitors and then the transistor, and then we'll install the IC sockets after that. And I'm going to start with the decoupling capacitors. These are the 0.1 microfarads. I'll install these and then I'll do the electrolytics. And I have basically a row of capacitors here. It might be a little bit off screen, but those are all that need to be installed. Next, let's install the microcapacitors. And I actually went ahead and installed the C5 here, which is 1000 picofarads. Let's go ahead and install the other ones. There's 4 more. And finally, the electrolytic capacitors. And there are 3 of them. One is a 100 microfarads, 6 volts. That's C10, which is right over here. I'm actually going to use 25 volts. I just like it that it's slightly bigger than the the 6 volt that I have, and it kind of makes it similar to the footprint here. So I'll use 25 volts and 100 microfarads. Gotta make sure we orient it correctly with the plus to plus and minus to minus. And then there are two 10 microfarads, 6 volts. I'm using 10 microfarads, 35 volts. As long as it's at least 6 volts and up, we should be okay. That's C11 and C16. All right, all the capacitors have been installed. I think it looks pretty good so far. There's one more item or component that needs to be soldered on, and that is the transistor. And we'll be using the 2N5129 transistor, and it kind of looks like this. If you remember, we used these transistors in some other boards that we installed in the past. I think one of them was in the ASCII encoder, the brute force ASCII encoder created by Lancaster, and we actually made a video about it. And so it's a 2N5129. Just got to make sure we install the correct one. And the orientation, it will be similar to the other ones, where we oriented in the same way that the silk screen is oriented, with the base pointing to the right. By the way, the base of a transistor is the center pin. And that is all. So we got all the solderable components installed. The next thing we will do is install the ICs into the sockets, and then try to insert it into the mainframe and give it a try. I actually really like the way the cursor board looks. Just these microcapacitors and that transistor just looks cool. Let's go ahead and insert all the ICs into the sockets. And we can use this document, I think it's on page 17 of the construction manual. It has the actual silk screen layout, and we can see which IC goes where. So we can basically reference that and also the parts list to see which one goes where. And let's go ahead and start with these right here. I think these are 7402s, and they go into IC5 and IC6. I actually had the board backwards, so let me undo this. Yeah, make sure the board is oriented correctly. So if we're looking at the silk screen here, the 555 timer is actually on the top right corner. So I just want to make sure that it's oriented correctly. So let me redo these IC5 and IC6. Again, I installed them the other way. When I had the board like this, I had pin 1 going to the right, and I just went ahead and installed it the same way. But now that the board is oriented differently, pin 1 is actually on the left side. So let me redo that again. Oh, by the way, if you can't find a 74 version of NIC, for example, I'm looking at the 7474 here, IC7. You can also use a 5474 that has the same functionality. I think these are military grade, possibly, and they can withstand higher temperatures and things like that. So they will actually work for our case. IC2 and IC4, according to this document here, well, actually, according to the silk screen, is calling for 8291, but according to this document on the parts list, it's calling for 8281 or an 8291. It's a divided by 16, but it also says it could be a 74197 or 74177. So I found a 74197 right here. Just one of them. Let me insert that into this position here for IC4. But I can't find the other one for some reason, the 74187 or equivalent integrated circuit. I just can't find it. So let me just go off screen and see if I can actually find it. Maybe I just misplaced it somewhere. But yeah, once I find it, we'll be back. Well, it turns out that I actually only got one 74197 IC when I first order all the parts for the TV typewriter, and I missed one, so I had to order another one. And it's been a few days since the last video, actually the last recording, when we assembled the components of the cursor board, and I finally received the 74197 IC, the second one. So we will go ahead and insert it into the cursor board. Let's take a look at the layout here to see where it goes again. So just want to make sure. So here IC4, it says 8291. If we look at IC4 for that, so IC2 and IC4 are 8291, or it can be a 74197, which is what we're going to use in our case. So let's go ahead and insert it into this position. Okay, it's in. I actually got another one as well. I'm still waiting on it, but I got a J version, so basically like a ceramic one. I think they look cooler that way. So I'm going to replace it once I get it, but for now we're just going to use this one. All right, let's go ahead and insert all of the boards that we assembled so far into the TV typewriter and do some testing. All right, so I just inserted all of the boards that we assembled, and we can just double check to make sure all the pins are actually aligned and in the correct positions. The way I inserted it is basically the timing on the board, since I think we're pretty safe with that one, aside from the crystal oscillator, which I still have some plans on replacing it and making it closer to the specified one on the construction manual. But for now, we'll just put it on the bottom. The next one is the cursor board, which we assembled just now. It's fully assembled. I don't think I'm going to do anything with it just yet. But I went ahead and installed the memory board on top here because we still need to insert the couple of these shift registers in while we're testing it. So that's why I put it on top. But we'll see. We'll still swap it around if we have to. All right, let's go back to the construction steps. I believe the last place we left off was right here. So it says add all the components to the cursor board, which we just finished with the last IC that we were missing. Set the TV typewriter up for a screen full of ads and add the board. I'm not exactly sure what that means. The display should not change except for the possible appearance of the cursor. So yeah, I guess the first thing we want to do is see if the cursor actually shows up. So let's try that. Let's plug it in and see what it shows. I've got the TV turned on, and the TV typewriter is also plugged in. So let's go ahead and power it on and see what it shows. Okay, so we're seeing the ad symbols as before. It's sort of stuttering. Let me see if I can fix that. This TV is not the greatest. The external monitor that I was using for the video out, the S video, is much better for displaying these characters. This TV is just really messed up, so I just have to play around. It's very finicky. All right, so here on the construction manual in the steps, it says, so it's going to show all the ad symbols, and the only thing, so the display should not change except for the possible appearance of the cursor. I don't see the cursor right now, and I actually suspect why I'm not seeing it. And I think the reason why is because these switches that we installed, you see I just touched the switches and it's already acting up, but these switches that we installed for the home and I guess the clear button, I think it might be installed backwards, basically upside down. So it's currently being reset all the time instead of accepting characters as it should be. So if I press the home button or the clear button, I don't know if you saw that, but the cursor just blinked quickly at the top left there, and then it went away. And I think another reason is because this other momentary switch is also upside down. So for example, if I press the repeat switch down, basically disable repeat since it's backwards, and also press the home switch down, basically disable clear, it should show the cursor blinking. So yeah, there you go. So we actually see the cursor blinking in the top left. So that's actually a good thing. We're seeing the cursor, but obviously these switches are backwards, and it should be an easy fix. We just have to resolder the leads to match up the footprint on the PCB correctly. But yeah, I think that's good. And then it says here that if you have any trouble with the cursor, check out the internal test points on the cursor board, which is, in our case, it's the second board on the stack, so we can't really reach to it. But like if we had problems with it, we would have to restack it and test it out that way. But it looks like the cursor, in my case, is behaving correctly. We're not fully finished testing it yet, but so far I'm pretty confident with it. So yeah, let's try to hook up a set of switches or a keyboard. Fortunately, we actually built a keyboard in a previous video. So here's the keyboard that we built. This is one of the keyboards that Don Lancaster designed and featured in a radio electronics magazine. So if you're interested in this keyboard, check out one of my previous videos where we built this. So the first thing are the two electrolytic capacitors here. I just want to make sure that they're actually rated for 12 volts or up, so maybe like a 15 volt capacitor. I believe the ones that I installed here initially were 25 or 50 volts already. The second thing is this Zener diode. I think it's a D27, if I'm not mistaken. It needs to be replaced with an 8 volt Zener diode. I believe I installed an 8.2 in my case, so I actually took this apart and reinstalled a different Zener diode. And the keyboard is basically just a direct connection from the encoder to the TV typewriter. I had to trim one of the connectors here on the side because the TV typewriter only had a small ledge and the connector was in the way. So let's go ahead and plug it into the TV typewriter, making sure to orient it correctly. Basically, positive 12 volts should be facing down, and I believe ground is facing up. Okay, I got it hooked up to the TV typewriter. Let's turn it on again and do some more testing. Oh, wait a second, we already had it on. Wow. That's one thing you got to be very careful with. Don't plug things in and out with it being powered on. So a mistake on my side. But we have it plugged in, and the TV typewriter is already running. Got the keyboard hooked up. Let's see what happens if we press a key. So nothing happens. All right. What if we press this home switch down? Since it's reversed, right now it's clearing it. Okay, nothing happens. What about the repeat switch as well? All right, so I got both of the switches down since they're reversed, and the cursor is up in the top left. What I actually ended up doing right now is swapping out the switches here, the home and the, I guess, the repeat switch. So it was backwards, but the reason why it was backwards, I believe, is, you know, the idea was to install the switches from underneath. So if you swap the switches upside down, they're going to be acting backwards, if that makes sense. So we forgot to account for that. But that's not a big problem because we can always just swap out the wires and replace or switch the functionality of the switches. Okay, so now we can press the home switch to clear the screen, and what that does actually is brings the cursor, which is right here, and brings it to the top left corner of the screen. So let's go ahead and try to do that. All right, so we have the cursor in the top left, and now we can actually press keys on the keyboard. So for example, if I press the space key on the keyboard, let me just move it a little bit this way. There you go. It makes the cursor move to the right. So every time I press the space key, it moves the cursor one position to the right. And let's see what happens if we go all the way to the end. Yeah, and it goes to the next line. And also, if we press let's press the CR, so carriage return, it makes the cursor go to the next line. What about the LF, the line feed? Yeah, line feed does the same thing. Okay, I think I'm pretty confident with the cursor board being functional. So now we can actually move on to the step 8, which is to add memory clock driver. So here it says to add all the remaining memory A board parts except IC1 through IC6, which are the shift registers. And we actually already did that in a previous video. So we installed all of the components on the memory board except for the shift registers. And then it tells us to do some testing for 2 groups of 512 dots using self-test or a scope. And we can actually do that with an oscilloscope if we have one, just to see, to make sure, to ensure that the highs are positive 5 volts and the lows are negative 12 volts. But I actually already did it off screen and it looked correct to me. So the next thing we're going to do is install the memory, the shift registers, and we'll start with a single one. In this case, we're going to install IC5 only, and do some testing with that. So let me power off the TV typewriter and insert a shift register into it. And the shift registers we'll be using are the 2524V Signetics. And as I mentioned previously, I believe these are authentic from 1973. I have a couple of these sets available on calxture.com if anybody's interested. There's a limited supply. All right, I'm going to go ahead and install it into IC5. And IC5 on the memory board is this IC right here. All right, so it's in. Let's power it on again. Let's clear the screen. And here on the construction manual, it says that we should be able to enter a P or an at symbol selectively in any position on the screen. So let's try that. I'm going to press a P. Well, it's not setting it. Actually, I just remembered we have to select the correct page. Oh, there you go. That's better. So we actually see all P's and ats, and it's just garbage data. Let's try to press the home screen. Yeah, it actually clears the screen to all P's. But now we can actually enter characters. Let's try an H. So H doesn't work. What about an at symbol? At doesn't work. You know, it might be this keep and change also. So the keep and change switch might be set correctly. Might need to be set correctly. Let's try it now. I changed that doesn't change anything. So the at symbols just doesn't want to work. Let me reset this again. So P. See, I can enter a P into it. What about an at? The at symbol is not working. I wonder if maybe just the key is wrong here, which is why it's not working. Let's actually go ahead and add IC6 to the memory board. Okay, and turn on the TV typewriter. All right, so I'm seeing a lot of P's and at symbols. So now it says you should get ats, zeros, blanks, and P's. Well, let's see if that's actually the case. If I press space, I should get a blank, right? No, I'm seeing zeros. That's interesting. By the way, the cursor for each character is actually showing up on top, which is unusual. Usually we see it on the bottom. So that's why the character is actually being populated underneath the cursor. So zeros, blanks, P's. Yeah, so I can enter P's. What about zero? Yeah, zero's not working. I'm guessing maybe the... Oh, I got a zero. The cursor just jumps back for some reason. That's weird. Yeah, I can actually enter zeros, but the cursor has to be right at the right moment for it to be entered in. That's strange. What about ats? Yeah, ats are zeros as well. I wonder if that at key is actually wrong. Let me reset the screen. Oh, look at that. We get all zeros for for when we reset the screen. Interesting. You should be able to clear the screen on command, again with the protect and page select switches properly set. Note that the keyboard encoder must put out either 100000 or all zeros code during clearing. Do not go on until you can erase and selectively enter the 4 characters when and where you want to. Well, I can't enter a blank. Oh, look what it's doing. That's interesting. So it's just erratic at the moment. Let me clear the screen. Yeah, it's acting strange. I wonder if it's related to the timing. That's interesting. It could potentially be the timing because of, you know, basically it has to be the exact time for a character to be entered into the shift register. So if the timing is off, it might make it erratic as well. So that's interesting. I mean, I can enter some characters in, and some of them need a couple of clicks for them to be entered in. And some of them are just the wrong character. I wonder if it's the encoder that's messing it up. Anyway, I'm going to go ahead and insert all the remaining shift registers into the memory board and see if we can start typing on the screen. Okay, so I just inserted all of the remaining IC shift register ICs into the TV typewriter and turned it back on. And we're seeing a bunch of random add symbols all over the place. Let me try to press the home key to clear the screen. So I'm actually seeing zeros. When I press home, I see zeros and a couple of question marks randomly. Wonder why it's doing that. Let's try to type something in. Okay, so I just typed in test and I got a T, a U probably, or a V. S-T. That's interesting. Also, the cursor went backwards one spot whenever I pressed the last T. Yeah, I'm seeing totally wrong characters from what I'm pressing. I mean, not totally. I see a couple of them that are correct. But let's type in, let's do a space. Look, if I press a space, that's what it does. It just gives me a bunch of P columns. Let me reset again. Let's type in hello world. Ooh. Yeah, that's not hello world. Although I do see a couple of correct characters. So, for example, the W and the R are correct. Huh. Interesting. Let me see if I can actually debug this. I hooked up the TV typewriter to a monitor, composite video output, just because it displays the characters a little bit better than the other TV. And I want to see if we can actually troubleshoot this issue and figure it out. So let me clear the screen. So I'm seeing all zeros, which is strange. It should be all blanks. And I guess there's a couple of issues that I want to resolve. The first one is that, like, if I type in some characters, the cursor sometimes goes backwards. That's weird, right? So we want to resolve that. And if I change the, if I switch the switch to subtract and try to type letters in, it actually inputs the data correctly. Like I'm getting all the wrong characters, but it's not going forwards and it's not skipping characters, and it's not like staying on the same position every time I select the character. It actually goes to the next one correctly, so that's good. So I have to figure out what the problem is with the circuit. Basically, inputting data going forwards is just not working properly. And also the actual characters that are being displayed. So for example, let me clear the screen again. If I type in A, I get a Q. S is correct. D is T. F is V. So QSTV. Interesting, right? Let's take a look at the 2513 data sheet. So on the last few pages here, let me see, it's page 46, I'm guessing. So if I typed in A, and the address, I guess, for A is address 4 is 1, and then the rest are zeros, and I'm getting a Q. So if we could take a look at Q, we have address A4 as 1, same as A, but also A8 is 1. So maybe A8 is 1 whenever we select A. When we select S, again, we get A4 and A5 ones, and A8 is also 1, which, if my guess is that maybe A8 is staying on or high all the time, so that's why S is actually showing up, because it's high. To display S, A8 needs to be high. And the next character, D, it should be 001, 000, and we are getting, for D, we are getting a T. So it's a 001, same as D. But then again, A8 is high, which is a 1. So I think A8 is always high, and basically the address for that's coming into the character generator is always high. So let's just take a look at the sheet here. So we have the pinouts for the 2513, and we have these address lines from pin 14 all the way to pin 22. And address 1, 2, and 3 are actually for the position of the dots, and it appears to be correct for all of them, so we're not going to look at those yet. But then address 4 through 9 are the ones that we actually want to look at, and it looks like address 8 is the one that's acting up. So pin 21 is, or appears to be, always high. So if we look at the schematic here, the character generator for the memory board schematic is right here, and pin 21 is A8, as it shows right here on the character generator, and that's actually the address that's coming in from the line register. So what I want to do is actually use my oscilloscope here to see what is actually showing on address A8 or pin 21 of the character generator, and then we'll work from there. I took a little break since we last looked at the TV typewriter and the issue that we were having with the wrong characters being displayed on the screen. Basically, the A was showing a Q and so on. And I was thinking it was probably an issue with the line register just not, I guess, not working, or something related to that. But I also suspect that maybe just the keyboard is giving us the wrong ASCII code, which I wanted to take a look at. But I actually put that on hold for a little bit, and I tried to change the crystal oscillator to a different frequency that I got on eBay somewhere. I actually installed it, and it just didn't work correctly. The frequency was way off. So I went ahead and reinstalled the 4.5 megahertz crystal that I had. Actually, a different one that I had. I put the other one aside. I actually got like 10 of them just to play around with them. And when I installed this one, all of a sudden I got the characters showing up correctly. So let me clear the screen. So for example, I can type in A, S, D, F. So that's showing ASDF, but I'm sure you can see what the problem is here now. Basically, the characters are malformed, or it kind of like squashes them together or something. So, I don't know what's going on with that. So for example, if I type my name in, actually let's try to just type in A. If I type in the letter A, you notice the cursor actually went back one spot. But if I just type slowly, it seems to be okay. I think there's like a line here in the middle. I think it's writing a line right in the middle for all the characters. I wonder if maybe... Yeah, I don't think it's the character generator. Oh, yeah, I guess it could be. We know for sure that the shift registers are working because we can type in all of the characters and have them display on the screen in the correct position. So that's good. The shift registers are working. I guess the memory is working. The cursor is showing up and it's blinking, but it keeps on going back occasionally. And by the way, it only happens when I do it forward for some reason. I don't know. It's strange. But anyway, I don't know if it's the cursor board that's having the issue or maybe it's just the timing. And I'm suspecting it's the timing. But we can probably look at that later. I think I just have to get another crystal oscillator, one that's closer to the specified frequency, but I don't have one at the moment. So we can put that aside for now and see if we can do some more tests with this. So I'm going to switch the switch here, the page switch, to page B and see what it shows. Okay, so page B is actually blank. Let me clear the screen. It's not going to clear the screen because there's no memory involved for page B. So yeah, that's... At least we know that the pages are being switched correctly. So we got page A here with everything that we just typed, and page B. I also have these strange lines on the left. I'm not sure where that's coming from. That's another thing that I wanted to take a look at. Okay, what about change and keep? So I guess what this does is basically, if I change it to keep, and I press keys on the keyboard, it should not change the value on the screen. So for example, if I press J, oh, okay, well the cursor went backwards. Okay, now it's back. It's jumping back and forth. Oh, there you go. Yeah, so again, the cursor is acting out, but we can see that whenever I press any key, it doesn't actually change the value on the screen. So that's good. That means the change keep functionality is working. I change it back to change. What about repeat? So let's try to press, let's try a B. No, let's try something. Let's try a Q. And then repeat. Let's see what repeat does. Question mark. Yeah, giving us a question mark for some reason. Okay, well, R. Yeah, repeat is not working. I'm getting question marks. Okay, well, we have to debug that. The clear screen or the home switch clears the screen. Right, and moves the cursor back up. Okay, well that's working. Well, it's been working since we've been testing with it. What about the cursor on and off? So it's off now and on. Okay, so the cursor on and off switch is working correctly. And the add and subtract. So the add and subtract, yeah, so this one basically switches which direction the characters are entered, whether they're entered going forward or going backwards. So right now it's an add, so if I type in A, D, D. It's going backwards. If I change it to subtract and type something in, it should go backwards. Yeah, so it's going backwards. In fact, it jumps all the way to the bottom there and types from there. And look at that. I can type as fast as I want going backwards. I press Control or something. Yeah, so it's pretty nice and quick going backwards, but forwards, it just acts up. So I just changed it back to forwards, and it's just jumping up and down, forward and backward. A little confused, it seems like. Oh, look at that. I typed in an @ symbol and it gave me a whole bunch of @ symbols everywhere. Let's see. What can we... Let me just try a question mark. Okay, what about some other symbols that we can type? Well, it looks like the characters are being generated correctly. One thing, as I mentioned, when I press the @ symbol, gave me a bunch of ats all over the place. Oh, I haven't tried the space yet. Okay, space is working. I actually saw something previously. When I pressed space, it gave me random characters all over the place as well. Yeah. So this is what I'm seeing when I press space. In fact, it does it for... It seems to do it when I press the @ symbol as well. That's interesting. Let me see. Control. Oh, it's going backwards. So line feed and the carriage return, they're okay. That symbol gives me this weird output. And also the space. Huh, that's interesting. Need to investigate that. Okay, so a couple of things that we need to investigate still. The space key, the @ key, @ symbol, giving us these weird results. The cursor, I guess, going forward, or the add functionality is just acting up. The cursor just being weird. And also the malformed characters, which I think is related to the cursor being weird as well, which is all related to the timing. So yeah, we need to investigate that. I'm not going to touch the timing just yet because I don't have another crystal oscillator that's close enough to the specified frequency. But I am curious about the @ symbol and the space key that's giving us strange results. Oh, okay. I can't even type in a space in this column here, so may need to look at the timing. It might be also timing related because it looks like this entire column is acting up, and the timing might be the timing defines which column and which row actually displays what. So that's interesting. I'm going to spend some time off screen just trying to figure out what's going on with this space key and the @ symbol showing us these weird results. So I was looking at the keyboard here to see what's going on with the space and @ symbols. So if I press the space, I get that. If I press the @ I also get that. And I realized that the @ symbol, when I actually type it in, that's actually an 8, right? So an add-in is an 8. And I was looking at the connections here on the top of the keyboard to see which pin on the connector they actually connect to, and it looks like the @ symbol and the 8 are both connected to the same one. So I think there might be possibly a bug on the actual keyboard layout here, and I looked at the original artwork for the PCB, and it looks like they're both connected to the same location. So I think it's a bug in the actual artwork, but I'm gonna investigate later, just to be sure. And I still haven't figured out why it's doing this whenever I press the at or the space. I did look at the ASCII code, and the space is correct. It's giving me the correct ASCII code. The at symbol is actually incorrect, so I'm actually getting the wrong ASCII code, and it's actually giving me the ASCII code for 8. And in fact, see, if I press 8, I get the same result as before. So yeah, this at and the 8 are tied together. So I think if I fix this issue here, basically make the at symbol behave correctly to actually output the ASCII code for at, it will probably display the at symbol. But in an effort not to make this video too long, I'm actually going to save this debugging and fixing issues on the keyboard, and probably the timing as well. I'm going to try to find a crystal oscillator that's closer to the specified frequency. I'm actually going to do that in the next video, where we will basically focus 100% on debugging and resolving issues in the TV typewriter. In this video, we assembled the cursor board, and I think it's working correctly, aside from the fact that it's going backwards sometimes whenever we type a character, but I think it's probably a timing issue. I'm pretty satisfied with that. Also, we finished the memory board by inserting the remaining components, which were the shift registers, and it looks like we're seeing all the characters show up on the screen in all the positions. So for example, if I type in A everywhere and then B, actually that's an S, it looks to be working. So I'm pretty satisfied with the memory board as well. I'm not fully satisfied with the timing board just yet because of the crystal oscillator, but so what we're going to do is we're going to make this video a little shorter than usual, and so we don't make it too long. We're actually going to cut it off here, and in the next video we're going to focus 100% on resolving these issues that we're seeing. So basically, number one is the crystal oscillator. That's priority number one, is trying to get this this frequency as close to the specified frequency as possible. I'm going to try to find another crystal if possible. If not, I'm going to figure something out. Also, I want to resolve this cursor going backwards occasionally. I think it's a timing issue, so if we resolve this crystal, I think it will resolve the cursor, but if not, we're going to debug that as well. The memory board is operational. I'm pretty happy with that. The keyboard also needs to be resolved, and also the issue with pressing space giving us these weird characters, so we're going to take a look at that in the next video. And also might need to rewire the at and the 8 here, because it looks like they're connected together. And I think that's pretty much it. Also in the next video, I'm going to hook it up to the TV that we were seeing earlier and try to get it working on that TV. And it does work on it. It's just that it's a little misaligned, and sometimes I don't see all the characters on the screen. So I want to use that TV and fix it, or use another TV that I can actually adjust the vertical and horizontal positioning on it, and also use the TV tuner instead of the composite video output for that. So be sure to subscribe if you haven't already, and I'll see you in the next video.